In this video, we'll move the Taylor series expansion from cosine to sine. So we begin with the cosine, which is ARRAY formula, cosine of the x values 0 to 6. And the sine dataset, which is ARRAY formula, sine of the x values 0 to 6. And the Taylor series expansion, which is the summation of a times x raised minus theta raised to the power 2n, where the value n is from 0 to infinity, and the value of theta is equal to k pi. So it is equal to k times pi. And a value for k, which is data validation, list of items, 0 to 0.5. So it is from 0, you can start at 0, which is the Maclaurin series, 0.5. Now we can calculate the expansion coefficient, which is ARRAY formula, -1 raised to the power n divided by, there are two parts. The first part is double factorial 2n, so FACTDOUBLE 2 times n. That's the first part. The second part, again, FACTDOUBLE, double factorial, 2n minus 1. So 2 times n minus 1. Then enter. And we correct this error. If n equals 0, this should be 1. So we correct this error. That is, if n equals 0. Then 1. Otherwise, calculate. Now it's corrected. Now we can complete the Taylor series expansion. So ARRAY formula, series sum of the x values, x minus theta, raised to the power 2n. That's raised to the power 2n. So 2n starts from 0, incremented by t. And the coefficient a will be this range. And enter. So we can increase this to 0.1, so 0.2, so we go back to 0. And we'll chart this. Insert chart. And we use scatter chart. Row 1 as header, and show the trend line. Polynomial, the type will be polynomial. The degree will be 6. And the label, use the equation for the legend position at the bottom. So here's our trend line and polynomial of sine and cosine to the 6th degree. We'll calculate this polynomial regression coefficients using Linest. To do that, we complete the Linest matrix starting with the power. This will be transpose 0 to 6, and the elements of the matrix is equal to ARRAY formula of the x values raised to the power 0 to 6. And now we can use Linest. Data y and data x. That's for the cosine in blue. Linest, data y and data x. That's for the expansion in red. And finally, Linest, data y and data x. That's for the sine function. And we compare these polynomial coefficients we generated, starting with x to the 0. The coefficient is 1, 1, 0. This 1, 1, 0. This is 0. 1.31 times 10 to the minus 31. Coefficient of x minus 0.0555 0.904. Coefficient of x squared minus 0.354, 0.225. Coefficient of x cubed minus 0.147, minus 0.358. Coefficient of x to the fourth 0.117, 0.0732. Coefficient of x to the fifth 0.0201, negative 3.13 times 10 to the minus 3. Coefficient of x to the sixth 1.07 times 10 to the minus 3, negative 1.52 times 10 to the minus 4. Suppose we move the expansion to the right, so k equals 0.1. This time it's 0.314 radians from cosine. Move it to k equals 0.2. Now it's 0.628 radians from cosine. And 0.3, it's now 0.942 radians from cosine. And 0.4, now it's getting closer to sine. And at 0.5, now is 0.55 radians from cosine. And they are now collinear with sine. And this values, the expansion approximates the sine function, and their data sets are the same. If we can set it back to 0, these values are the same. Likewise, the data sets are approximately the same. This completes the use of Taylor-Maclaurin series sum, Linest polynomial regression, double factorial, to move the Taylor series expansion from cosine to sine.